Hello, hi, namaste. This is Surabhi, your master teacher of chemistry at Vedantu. Hello, good evening. Yes. Hey Sudarshan, hey Agnivesh, hey Aditi. Hello, hi Srilata, hey Sureka, hey Durga. What's with the name? Good evening. Hey Johan, hey Srishti. I'm late? No, come on, I'm on time. Huh. So, shall we start? One short revision of the whole chapter is matter around us pure. Of course, you all were waiting for. हाँ, चलो. So, in today's session, we'll complete the whole chapter. Is matter around us pure? So, what do you think? Is it pure? No? Very excited? That's nice. I'll let you know, Sudarshan. Hey, Aman. Hello. Good evening, people. Hey, Anshita. Okay, so we'll start. Thank you. So, what exactly is matter? So, matter is something which has mass and occupies space, right? Which is something everyone knows. Come on, so easy. So, matter, how can you define matter? Matter is something which occupies space and has mass. So, the chapter name is Matter Around Us Pure. So, what do you think? Is it yes or no? What's your answer? Yes or no? Who's that uncle? Yes, for 10 students also, whoever is preparing for the competitive exams, this will be very helpful. No? Yes? No? Na. So there are no pure substances. That's what you are saying. Yes, yeah, no. I see yes. No. Na is also there. Okay, that's what we'll learn at the end of the session. Uske baad you will have a, you will be very confident with the answer. Is matter around us pure? Yes, yeah, no. Okay, you don't have to think about it. Na munna, na. Acha, not all matter is pure. Very good. So, what are the states of matter? Solid, liquid, gas, right? So, on the basis of the arrangement of the particles, we have generally the matter has been classified. Generally, I know there are 5 states of matter. So, generally, the matter has been classified into solid, liquid, and gas, right? Yes. Ha. So, but based on this, whatever we are calling purity, see, in whatever we say in everyday life, what is pure according to us? So, for example, Hanji, this water is pure. That means it does not contain any impurities, right? For example, according to us, what are impurities? If you see some dust particle or if you see some insect, so that is what is impure, right? Then we won't drink that water. So, from the point of chemistry, what is a pure substance? What is a mixture? So let us study about that. What exactly is pure substance? A pure substance has to be made of only one type of particle. That is it. Single type of constituent. That whole substance has to be made of only one type of constituent. Then it will be regarded as a pure substance. When it comes to mixture, I'll take water, I'll add lemon juice, I'll add salt to it, sugar. So this is obviously you are mixing many things in whatever the proportion you want. Okay, so that is something, it's not made up of only one type of particle, right? So that is mixture. But you might be wondering, if I say carbon dioxide, yes, it is a pure substance. And the next question will be, how? So carbon dioxide may you have carbon and oxygen. How is it pure? The thing is, carbon dioxide is a compound in which, so the carbon and oxygen has been combined chemically in a definite proportion, right? It's not like, have you ever seen C2O, carbon dioxide? So in your place, carbon dioxide is C2O. Yes? No, right? Na, because we all know one atom of carbon will combine with two atoms of oxygen, only then only it can be called as carbon dioxide. So that is what is definite or fixed proportion. So pure substance may will have two types, elements and compounds. They both are pure because element may to see, if I take iron, what else it is made up of? Go on dividing it, you will end up getting only iron atoms, right? You won't get oxygen here, right? So obviously it is made up of single type of constituent. So it is a pure substance. And when it comes to compounds, even though compound is a substance which is made by the combination of two or more different atoms at a fixed ratio, so as it is chemically combined in a particular ratio, it can be called as a pure substance. Yes? Okay. So pure substance made up of only one type of constituent and cannot be separated by physical methods. Acha, you tell me guys, I'll give you water, okay? Only water, H2O. And I want you to separate water into hydrogen and oxygen. Which method will you use? Which method will you use? Thank you, thank you, thank you. Evaporation, filtration, sublimation, hand picking, electrolysis. Everyone is saying electrolysis. So it is not a physical method. You all agree? Electrolysis is a chemical method. You are passing electricity and then there will be decomposition. So you take any chemical compound, you take any pure substance, element, yeah, compound, you cannot separate it by physical methods. Will you agree with me? Yes? You can't separate. Why? That's what I'm saying. Electrolysis mein you will pass electricity, so or the water will be electrolyzed and then you will end up getting hydrogen and oxygen at the respective electrodes, right? Of course, yes. Give me a high five. Good job. That is what is pure substance. Bas itna hi hai. Ho gaya ji. And then mixture. I told you, lemonade. So it's not like okay Surabhi, take 2 grams of sugar and 1 gram of salt, exactly. Add 5 ml of lemon juice to 20 ml of water. Have you ever seen someone preparing lemonade like that? It has to be in the 1:2:1 ratio only, otherwise you won't get lemonade. Arey bhai, no. If I like sugar, I'll add 4 grams. Hai na? Right? Yes or no? No. So here, the made up of different constituent in uneven ratio. You take it. If you like salt, you add more salt. I like sugar, I'll add more sugar. But you will end up getting the same mixture only, if you want to make lemonade. Right? है ना? Hey Shika, क्या हो गया सुदर्शन? Hey Yashaswini. Okay, and these mixtures, they can be separated by physical methods like heating using filter papers. You can maybe, heating or by using filter paper, that is chromatography, about which we will study in detail today. Evaporation, yes, we can separate it, right? So example, milk. Milk is a mixture. Forget about adding sugar to it or Horlicks or Bonvita. Milk itself is a mixture. But you won't be able to see anything. We thought milk is a pure substance. Everyone says, hey, milk. Pure as milk. But in reality, milk is a mixture. Right? Water will be present. Acha. Hey, Seshu. It is a heterogeneous mixture. It is not homogeneous. Milk is a heterogeneous mixture. It appears to be homogeneous, but it is not. Okay, so these are the examples. So pure substances, it has been again further classified into elements and compounds, which by now we know what are elements and compounds. Periodic table though, we have been studying, right? 118 elements. So they are the basic form, right? Elements are the basic form. So then they will undergo the reaction or the chemical bonding, chemical combination to give the compounds or mixtures, right? I'll tell you. Okay. So elements, they are the purest form of matter which is made up of only one type of constituent particles. Oxygen, iron, gold. So you can take any example, whichever is there in the periodic table, they are all elements only, no? So and then you won't see iron में क्या है? सिर्फ only iron atoms, right? If you take sodium, you will find only sodium atoms. है ना? Okay, easy peasy. So elements based on the properties. We know, right? Even in the periodic table also we have metals, non-metals, metalloids. So based on the properties, the elements has been further classified into metals, non-metals, metalloids. Now who can tell me what are the properties of metals? General properties. The moment you think about metal, what pops up? I'll tell you, whoever is asking me to define homogeneous and heterogeneous, I'll do it, children. The whole chapter will be covering today. No ji, aaj nahi hai. Okay, they are lustrous. I'm getting the answer. Lustrous. Okay, what exactly is it? So they will have this reflective surface, shiny surface which reflects light. That is the reason people love wearing gold, silver, right? And it shines. So metals are lustrous, very good, malleable. So you might have seen people use aluminium foil for the package of food, or the Rutherford. Which metal did he use? Thin gold foil. So where the property of metals in which they can be beaten into thin sheets is what is known as malleability. And the other one is, what is this? Conduction of heat and electricity. Very good, very good. Lustrous, sonorous. So it produces ringing sound, right? So ductile is, it can be drawn into wires. So whatever we use here, है ना, इसके अंदर metal है ना, obviously it's a good conductor of electricity. So the metals, they have the property in which they can be drawn into wires. So that is what is known as ductility. So metals are said to be ductile, and you all told me that it is malleable also. That is, it can be beaten into thin sheets, and of course they are good conductors of heat and electricity. Look at your kitchen. So the utensils are made of alloys or metals, है ना? Why? Because they have to conduct heat, otherwise the food won't be cooked. And electricity, metals are very, very important, right? Yes. No, air is basically a mixture. Okay. So properties of non-metals. See, we always study about the properties of metals and we'll just add non to it. है ना? Non-metals, yes. Non-lustrous, non-conductors of electricity, non-conductors of heat. Ductile, malleable, na. They are also non. So they show variety of colors. What is the physical state of non-metals is they are either solids or gases. The only liquid non-metal is bromine, right? See the children, the exceptions are very, very important here. Okay, so here also we will see generally metals are solid, but you have liquid metal, that is mercury, and we say generally metals are hard, but you have soft metals like sodium, potassium, lithium, which can be cut using knife. And we feel that they are all ductile. No, they are all malleable. No, zinc. No, it is not. You cannot beat it to a thin sheet. So here, when it comes to the properties, please focus on the exceptions. Okay. And coming to non-metals, we say they are poor conductors of heat and electricity, but you have graphite, even though being an allotrope form of carbon, which is basically non-metal, which has to be a bad conductor of electricity, but graphite is a good conductor of electricity, right? And iodine, which is a non-metal, it is actually lustrous. So these are the exceptions which you have to remember, because see, everyone remembers, India, yes, which is the capital city, everyone will remember. So when you talk about the exceptions, that's where you have to put some little extra effort, right? So they will ask you questions related to exceptions, so please focus on that. Yes, lead dear. Okay. Now you have metals, you have non-metals. Metals are pure, ductile, malleable, good conductors of heat and electricity, and here you have non-metals which are poor conductors of heat and electricity. And there are the different set of elements that have properties that are intermediate between the metals and non-metals. Acha, so if this is the periodic table, you will find the non-metalloids here, right? So it is basically the transition phase. So from metals to non-metals. So they will have the intermediate properties of metals and non-metals. For example, you take silicon. Take it at the room temperature, it does not conduct electricity. No. But with the increase in temperature, silicon starts to behave as a conductor and it starts conducting electricity. That is the reason it is used in the solar panels and all that. है ना? No, water is a compound. See, elements have been classified into metals, non-metals, metalloids. But water is basically, it's a compound, right? है ना? Yes. It depends on the conditions. For example, silicon, as I told you, at room temperature, it's a very bad conductor. But as you increase the temperature, it starts behaving as a conductor. Yes? No, dear. It's not there. So because after this, we'll have a one-shot revision on other chapter, that is atoms and molecules, and then there will be a mentee battle, okay, between the two chapters. Yes? So for that you have to stay till the end. So now coming to the compound, water. Let's take an example of water. So it is the purest form of matter which is made of two or more different elements. See, oxygen is not a compound. Hydrogen gas is not a compound. This is a molecule, but it is not a compound. So compound mein the two or more atoms will be always made of two or more different atoms. Okay? Yes. And combine in a definite ratio. For example, let's take ammonia. In case of ammonia, this definite ratio by mass, okay? So here, always the ratio will be 14:3 only. You take ammonia from as a byproduct, or you are synthesizing ammonia, or it has been released as a pollutant, anything. So it will be nitrogen and hydrogen will always combine, or it will exist in the fixed ratio 14:3 itself. Okay? Chal. So what are the compounds? See, the constituents of a compound cannot be separated by physical methods. So I asked you, right? How can you separate hydrogen and oxygen from water? You said electrolysis, which is not a physical method. Maybe the physical techniques are like this, evaporation or sublimation, chromatography. Using that, the compounds, constituents can never be separated. That is the one thing. So these are the differences between compound and mixture that I'll tell you later. Okay. Yes? Of course. That's nice. We'll start it soon. Then properties of compounds. Elements react to form compounds, Hanji. So the new substance formed has totally different properties. You all agree? Hydrogen and oxygen, they have their own set of properties, but water is nowhere similar to these constituent elements. So because it is a new compound, new substance which has been formed with its own properties. So hydrogen and oxygen's identity has been lost. So जो भी molecular oxygen में whatever the properties oxygen was possessing, it will be lost when a new substance is formed. That is the meaning of the second point, that a new substance formed has totally different properties compared to the reactants, and the constituents can be only separated by chemical or electrochemical means. Okay? Yes, G. Now, mixtures, compound के बारे में we studied. Now coming to mixtures, so what are mixtures? You will find numerous number of examples. Maybe oil plus water is also example of mixture. है ना? Sand plus water is a mixture. Sand plus salt is a mixture. Lemonade is a mixture. Milk is a mixture. Blood is a mixture. So based on the composition, whether there is uniformity or not, so the mixtures has been further classified into homogeneous and heterogeneous mixture. Can you tell me what exactly is the meaning of homo-hetero? What is homo-hetero? Hanji. Homo-hetero. What is the meaning? No uniform composition, same phase, okay? Similar in terms of uniform, non-uniform. Homo is almost like same, hetero is different, right? So what will be same, what will be different? Very good. Homogeneous mixture may there will be uniform composition. Uniform composition. So what you can do is take a glass of water and just add a drop of ink to it. Just add a drop of ink. So you can see after a while it makes sure that it has been distributed uniformly. It doesn't stay at the top or go and settles down at the bottom. है ना? Or you prepare lemonade and start drinking it. So at the top as well as the bottom it tastes the same because of the uniformity, or you can also call it as homogeneity. Children, if you have any doubts, please let me know in the comment section. So about the physical states and all that, so we are planning to make a video soon. Okay? Why? Okay. So homogeneous mixture, sugar solution, salt solution, even the alloys, they are homogeneous. So what are alloys? We all use steel, no? So in that, can you see, oh, this is iron, this is carbon, this is iron, this is carbon. Will you be able to differentiate? That's my first question. Steel है ना? सबके घर में है ना steel? Will you be able to differentiate? It's basically an alloy. It's a mixture because there is no chemical combination. There is no chemical reaction. There is no sharing of electrons, no gaining, nothing. So it's basically a mixture in which, so in a right proportions, two or more, maybe metal and in a very small composition, a non-metal has been mixed. Will you be able to differentiate? This is iron, this is carbon. You can go check. Take any steel utensil. No, right? है ना? Right? No. So that exactly what is known as homogeneity. So there will be one component has been uniformly distributed all over the mixture. So this is exactly what is known as a homogeneous mixture. So as there is this homogeneity, it won't be that easy to differentiate the component. So for example, if you take salt, add it to water, will you be able to see the salt particles? No, right? Why milk is heterogeneous? I'll tell you. Yes, atoms and molecule structure of atoms, sabka hoga ji. You don't have to worry. And then homogeneous mixture mein true solutions and alloys. So alloys you all know. So basically, the steel or brass, bronze or solder, so many alloys which we have started using, right? So generally it's basically where you are, what they do is, so when it comes to homogeneous mixture, one there will be a major component and the other one will be a minor component. Okay? When it comes to alloys, so what they will do, first they will melt the major component which has been taken in a large amount. Okay, they will melt it, and at the right proportion, it's not like, you have taken a 10 ml, okay, it's okay, I'll add only 2 ml. No. So the right proportion, the minor component which has been melted will be mixed with this major component. That's how the alloys will be formed. That is the reason you will be able to observe homogeneity. Okay, and true solutions, salt solution, sugar solution, or the ink solution, they're all examples of true solution. Yes? Okay. True solution is a homogeneous mixture of two or more substances in which the solute has been dissolved in a solvent. So whenever it comes to solution, you will have two components. Okay, two components. One is solvent and the other one is a solute. Okay, let's take an example. Okay, I'll take Arushi. I'll ask Arushi, and I'm taking your name here, and Varun. So I'll ask both of them to prepare sugar solution. Okay, to prepare sugar solution. So what Arushi does it, she'll take 5 ml of water and she'll add 20 gram of salt to it. Okay, and what Varun does it, he'll take 20 ml or 50 ml of water plus 2 gram of salt. Which according to you is right? Which according to you is right? Arushi ya Varun? Hey Gupta, Arushi ya Varun? Varun sir? Even Arushi is agreeing. है ना? Because we always know the solvent which is dissolving, because here the water has to dissolve salt in it. So obviously it has to be taken as a major component, right? And the solute must be always taken in a small quantity or as a minor component. So Arushi will be wrong because 5 ml water में 20 gram salt. How can it even dissolve? है ना? And Varun will be right. So these are the two components of a true solution. And alloys is also a uniform mixture. So one has to be a metal, obviously you might have seen. So we have this zinc and copper ka alloy or carbon and iron ka alloy, right? So why are we even combining metals is to get the desirable properties. For example, if you take pure iron, no. It's not that strong. Okay, so to increase its strength and to prevent it from rusting, the stainless steel, it does not undergo rusting. We'll add chromium to it. So for these to get the desirable properties, we are forming alloys. Okay? Okay. It's not there here. Impossible. Now coming to the heterogeneous mixture. See, not at all. They are non-uniformly distributed. So you take oil plus water. Will you be able to differentiate just by looking at it? They will form different layers, right? Oil will be floating on the top, है ना? And sand in water. The sand will go and settle down. So there is no uniformity in the distribution of the component. Such mixtures are called as heterogeneous mixtures. Yeah, most of the time they will have you can actually physically you can differentiate the layers. But when it comes to milk and blood, so that is the reason we mistake it as a homogeneous mixtures, because you're not able, because the particles has been microscopically dispersed, so sometimes you won't be able to differentiate. In most of the case in heterogeneous mixture, so as they are forming physically distinct layers, you will be able to differentiate. Yes, got it, very good. So heterogeneous, oil, they are immiscible with each other, so they do not mix with each other, forming two different layers. This is what is known as heterogeneous mixture. So heterogeneous mixture maybe so you have two types, suspension and colloids. So what exactly is suspension? Very simple thing. You take a glass of water, add mud to it, mud, not sand, mud. Okay. So firstly, few will go settle down, few will be top floating, few has been suspended. So this is how the mud ka mixture looks, mud plus water. So here the one thing is the particles, they do not dissolve, right? The particles do not dissolve. What are the properties? And you will be able to see the particles because the size of the particles will be greater than 1000 nanometer. Okay, and after a while, if you keep it undisturbed, so all these particles will go and settle down at the bottom. So using filtration technique, can I separate them, mud and water? I can, right? Yes? है ना? हाँ. Yes, milk is soluble, So this is what is suspension. Okay, so these are the properties. So the particles are visible by naked eyes because of the particle size which is greater than 1000 nanometer, and the separation technique will be filtration, and it shows the Tyndall effect. So for example, you can take chalk powder and then pass the light ray through it. So you will be able to see the pathway of light because these particles will scatter the light, which is known as Tyndall effect. The another property of suspension. Okay, hey Satyajit. It is heterogeneous. See, it's not about whether it is soluble or insoluble. It's about the properties of milk, right? Okay. So properties of suspension, it is a heterogeneous mixture. Yes, particles can be seen by the naked eye. Yes, because the particle size will be greater than 1000 nanometer. And the solute particles, when you leave it undisturbed, it will settle down because the particles are unstable. So obviously you can separate them by filtration. Okay, but they can ask you suspension, of course. It scatters light, but once the suspension breaks and the particles start settling down, then though there won't be any Tyndall effect. That is also important. You should know what kind of suspension is it. So the suspension has been broken and all the particles have settled down, then of course it does not show Tyndall effect. Okay? Hey Soumya. Okay. So Tyndall effect, yes. That is what is. These are the properties of suspension. And now coming to properties of colloids. The particles of a colloid are uniformly spread throughout the solution. So see, that is the reason not only you, everyone mistakes it to be a homogeneous mixture because the particles are not visible. They are not seen. You cannot see them by naked eyes because its size, the particle size will be from 1 nanometer to 1000 nanometer. So you won't be able to see it by naked eyes. So what we feel, acha. So as you are not able to see the particles, we assume it is a homogeneous mixture, but in reality a colloidal solution is a heterogeneous mixture and not a homogeneous. Yes? Okay. So because of the small size, you cannot see it. So they are not visible by naked eyes. That is the first property. And yes, it shows the Tyndall effect. So it does not settle down. Okay, the particles does not settle down because the particles are quite stable. Then how to separate it? What do you think? In case of solution, evaporation is the right method. In case of suspension, we can use filtration. Colloids mean you are not able to see the particles. They do not settle down either. Then what is the method that can be used to separate the components of colloids? What do you think? Hey, hello. Thank you, Kaustuba. Hey, Anushka. Centrifugation. Very good. Okay. So this is what is Tyndall effect, right? So it is basically the scattering of light by the particles. So, just imagine yourself in a dark room and then suddenly through a small hole, a ray of light comes in. So then you will be, of course, you are able to see the pathway of light because the particles, the dust particles, so they are scattering the light. Or, through the canopy of forest, you will be able to see the pathway, right? So there also the mist particles, they are scattering the light. So this is what is known as the Tyndall effect. So how we had two components in case of solution. Even in the components, colloid may also we have two components. One is dispersed phase and the other one is dispersing medium or dispersion medium. Because many people ask me, ma'am, cheese, no, is it a solid? Toothpaste, is it a solid? Shaving cream, is it a solid? Foam, what kind of state of matter does it belong to? These are basically mixtures. Okay, in case of mist, what happens? The liquid particles has been dispersed in the gaseous phase. So that is the reason obviously you cannot tell. And in case of cheese or jelly, how can you say it is solid? Because solids are supposed to be hard and rigid, but jellies are not at all hard and rigid, right? But then what are they? So should we classify it as a solid? Yeah, liquid. It is basically a colloid in which, so in this solid dispersion medium, the liquid dispersed phase is there. So that is the reason you find it in those textures, right? Because that is a common usual question students ask me, ma'am, what is the state of matter of this or this or this? So it's not only solid, liquid, yeah, gas, because most of the substances around us is a mixture, right? You know? So these are the types of colloids. See, fog, gas is the dispersing medium, and then the dispersed substance is liquid. So that is the reason, right? So you won't be able to say it is just a gas, but you're even, whenever there is fog, you even feel cold. So whenever you walk through it, you feel like the water thing, the droplets, right? The whipped cream, milk is also a colloid. Mayonnaise, butter, cheese, right? So these are the examples of colloids. So types of colloids you will find, sol, emulsion, aerosol, solid foam. So these are the types of the colloids. Yes, okay. Because there is no reaction between nitrogen and oxygen, dear. Why is it a compound? So compound, what is the definition of compound? So there has to be a chemical combination, right? So air is basically a mixture. It's a homogeneous mixture where you will find nitrogen, oxygen, carbon dioxide, methane in their fixed proportions. That's it. Okay? Yes. So solutions, components है solute, solvent, हो गया. Now the thing is, it's not like they have a fixed composition, right? As I told you, you can go on adding, if you like sugar, add 3-4 spoons, 3-4 grams. If you don't like, add 2 grams. So the composition can be varied, right? So the relative proportion of solute and the solvent can also vary. This is supposed to be solvent, okay? The solvent. It can be varied. Then how to know what is the amount of solute present in the given solutions? So depending upon the amount of solute present in a solution, it can be called as concentrated solution. That is, if the amount of solute is more, it is concentrated. We say, right, concentrated H2SO4, dilute H2SO4. So what is that? In case of dilute H2SO4, we have added more water. Concentrated means the amount of H2SO4 is more, which is basically a solute. Right? So this is the difference between concentrated and dilute solution. Dilute solution means the solution will contain less amount of solute because solvent will be more. So that is the difference between concentrated and dilute solution. Okay. So what is a saturated solution? When no more solute can be dissolved in a solution. Okay, let's take an example. How many of you likes pizza? Water is a solvent here, alcohol is a solvent, acetone is a solvent, carbon tetrachloride is a solvent. Yeah, how many of you likes pizza? You all like pizza. How many can you eat? How many pizzas can you eat at one go? How many? One. Only one. One slice. That's it. I can have 2. 3. Okay, now I see 1,010 ones. Okay. So on an average, I'll take 3. 1 medium pizza. Acha, what about these pizza mania? Domino's wala. How many can you eat? 1 is enough. Only is enough. 3 slice. Acha. Okay. I'll take 3 on an average. So Naitik loves pizza. Okay, he can have 3 pizzas. So first Lekha will go and she will buy him a pizza and he is very happy, he'll eat it. Okay. After a while, Alia will go and she will also buy him a pizza. Again, he's happy. Okay. And then Vilas will go. He's like, hey Naitik, you like pizza, no? Chalo, we are friends. So I'll get you a pizza. So now he has had 3 pizzas. Then I'll go to Naitik. Hey, you're my student, right? Come on, I'll treat you a pizza. Will he be able to eat it? No, because he has reached its capacity. The maximum number of pizzas he can eat is 3. After that, no matter, you go on just keep the pizzas in front of him, he won't be able to eat it because he has reached its capacity. Even in case of solution, it's the same. Acha, you will add 1 spoon, okay, the water will dissolve it. 2 spoons, okay, chalo. Bichara, 7 spoons of sugar, how will the 20 ml of water can dissolve? So once it has reached its capacity, that is how much solute can it dissolve. So such kind of solutions is what is known as saturated solution. When no more solute can be dissolved in a solution at a given temperature, it is what is called as a saturated solution. But the thing is, it depends on the temperature. For example, at 25 degrees Celsius, the solubility. So what is solubility? The amount of solute present in the saturated solution. Okay, if the solubility is, for example, 25 gram, at 29 degrees Celsius, it will be more than that, it will be 28 gram. So with the increase in temperature, the solubility also increases. So it is very, very important for you guys to mention at the given temperature. Whenever it comes to the saturated, unsaturated solution, solubility, you must mention at the given temperature. So when no more solute can be dissolved from a solvent at the given temperature, such kind of solutions are said to be saturated. I'm saturated. So after reading 3 pages, I'm like, oh, I'm saturated, I cannot take it anymore. After attending 3-4 lectures continuously, I say I'm saturated. So that means I cannot take it anymore. So that is the meaning of saturated solution. Okay? Yes. So concentration, see the difference between solubility and concentration, you have to know, children. So what exactly is concentration? The concentration of a solution is the amount of solute present in a given amount, maybe mass or volume of solute dissolved in a given mass or volume of solvent. So we are not mentioning it has to be a saturated solution. Let it be any kind of solution. Saturated, yeah, unsaturated, any given amount of solute. How much, what is the concentration of a solution? So it is basically the amount of solute present in the, it may be in terms of grams or ml. So in the given mass or volume of a solvent is what is known as concentration. So amount of solute divided by amount of solvent, or amount of solute divided by amount of solution, but this is what we generally use. Okay, amount of solute upon amount of solution. Okay. See, what is saturated is, so everyone will have some limit, right? So you can sit and study for 4 hours, maximum 4 hours. At a stretch, 4 hours. After that, you need a break. So your mind cannot take it anymore. So even in the same way, the solvents, so they cannot just go on dissolving any amount of solute you add. So at one point, they cannot dissolve the solute anymore. At that point, at that given temperature, the solution, it is said to be saturated. Cool? Yes, so that exactly is the reason. So with the increase in temperature, so what happens? The kinetic energy of the particles increases, the intermolecular space between the particles increases, so the solubility of the solution also increases. Yes, got it everyone? So let me have some water, okay? Yes. You know the sugar solution when you are preparing the jamun, है ना? हाँ. So there also we add lot of sugar. At the room temperature and at the higher temperature, it's different, right? The solubility is different, right? Got it now? Why are we even heating it? You don't have to. But to increase its solubility, we are heating. Okay. No, G. So how can you calculate, determine the concentration? So it is using these methods. Okay, so one is the mass by mass. See, mass of solute divided by mass of solution into 100. It is mass of solution, not solvent, because whenever they ask the numericals, they will give you the solvent, they will give you the mass of solvent, not of the solution, most of the time. So in that case, you know what you have to do? You have to calculate the mass of solution. It is simple. Mass of solute plus mass of solvent will give you the mass of solution. So please do not get confused. So first is mass by mass method, mass of solute divided by mass of solution into 100. Okay. So after, yes Varun, so I'll take your question, I will answer that. What happens when the temperature starts decreasing? Because at the higher temperature, it has dissolved everything. But as temperature goes down, what happens? Have you heard about the process crystallization? That is somehow related to it. Keep thinking, I'll answer the question very soon. So mass by volume. See, the only difference is there you took mass of solution. Here we are taking the volume of solution. Bas. That's the only difference. Yes? Okay. Now coming to the very important topic. See here, what are the, till now whatever we learned, you have to focus on the differences between, let me tell you the differences between the solution, colloid and suspension, okay, with respect to the particle size, the separation technique, whether it shows Tyndall effect or not, whether the particles settle down or not. So that is something important, and you have to know the difference between compound and mixture, right? Okay. Now these are the separation techniques. So one thing we know, compound, to using this we cannot separate, right? So I told you so, we have prepared so many mixtures. So chalo, I took ink, I added it to water, mud plus water, okay. And then we even prepared sugar solution, but we want to separate them, and we have milk also. So how to separate it? Let us study one by one. So first is evaporation, which we use in everyday life. Evaporation is something, it's a very common technique. So here we have to take some solution. See, we are not heating it directly over the flame, but over the boiling water. Why? Because evaporation ka na bahut disadvantages hai. One thing, the compound, the mixture may undergo decomposition, okay, or it might get charred. So what happens, you take a spoon of sugar, okay, and start heating directly over the flame. After a while you will be only left with some black powder. Have you tried it? Yes? Hey Yashasvi, have you tried it? Take a spoon of sugar and start heating it directly over the flame. After a while you will be left with only carbon. So these are the few disadvantages of decomposition, evaporation. Okay, the compound, this mixture may undergo decomposition, it might get charred. So that is the reason we'll always we prefer to heat it over boiling water, not over flame directly. So they might ask you this question, reasoning one. Because what is there in sugar? It's basically sucrose, carbon hai, hydrogen and oxygen. So when you start heating, hydrogen and oxygen will go, you'll be left with only carbon, hai na? Hey Diya, yeah. Very good. So this is what is evaporation. So you will take ink. Ink is also a mixture. It contains water and dye. Okay. Now I want to separate water and dye. I want to know how dye looks. So you have to take it in a watch glass. Okay, this is what is called as watch glass. Okay. So you hear, or sometimes they will take petri dish. So usually we'll take the watch glass. And then, so what happens when you start boiling it, when you have kept it over the boiling water, so all the water will evaporate and you will be left with the non-volatile, that is which has high melting point, boiling point, and which is volatile. For example, if you take kerosene and salt, you keep it outside. So this kerosene, it will just evaporate, right? At room temperature, you don't even have to heat it. So such kind of components are said to be volatile with very less boiling point. Okay? Yes? Okay. So for separating a mix of salt and water, you have a mixture of salt and water, you start heating it, all the water will get evaporated, you will be left with salt. Okay? Yes. Next is centrifugation. So centrifugation, even though it's a homogeneous mixture, as you are unable to see the particles because of its very small size, which is 1 nanometer to 1000 nanometer, it is difficult for us to separate it by filtration technique. Yeah, evaporation. Have you ever tried this? You heating milk and then at the end you will end up getting water and Amul milk powder. ऐसा कुछ हुआ क्या? So this we use a lot in laboratories. No, right? So how to separate? So what exactly, how the centration, how the centrifugation works is, so for example, you know, right, at home, your grandmother or mom or dad, anyone, they will prepare butter, no, from buttermilk, milk. Have you ever used? Yes. So blood test mein also they will use this. Making curd, I don't think they use centrifugation. The churning process in the songs Krishna and all that you might have seen. No. So that is the same thing. So when it starts rotating at a higher speed, so what happens? The high dense, the denser particles are pushed down and the lighter particles will stay at the bottom. See, because after churning, the butter or the cream will start floating and the buttermilk or milk, it will stay at the top because the butter or the cream is lighter whereas the milk is denser. The same thing happens here also. This is what is known as centrifugation. Makhan. See, I'll tell you, the blood test, people will say, right, blood test and all that, there, the principle, what are they using? It is actually centrifugation. Okay, and even so to prepare butter out of milk, buttermilk, so they use centrifugation technique. Okay, yes. So sometimes the solid particles are in a liquid are very small. So they will pass through the filter paper. So of course you cannot use filtration technique. So then that is when the special technique called centrifugation will be used. For COVID-19 test. So the denser particles will be forced to the bottom and the lighter particles stay at the top. This is what is the principle of centrifugation. See, principles are very, very important. You have to remember. It's not about take a test tube, then add milk to it, keep it in the centrifugation, and then press the button. It will start rotating at a greater speed and denser particles are forced. See, anyone can explain the procedure, right? Once we have seen, we will explain. But it's about the principle. It's very, very, very important. Okay? Yes. So what are the applications of centrifugation? It is used in the diagnostic laboratories for blood and urine tests. So whenever we go, they will take the blood, blood test karwana hai or urine test. So what they do is, it's basically centrifugation. And dairies and home to separate butter from cream. Even in the washing machines also, so it will squeeze out the water, right? So it will start running, turning around. So the water will be squeezed out. So that is basically centrifugation. Okay. Yes. Next is separation of immiscible liquids. So you have oil and water, oil plus water. The good thing is you are able to differentiate it. You can see, right? Acha, oil is here, water is here, and this is the layer which is separating them. So this is called as separating funnel. Oh, it's written there, right? Okay, and you can take kerosene or kerosene and water, oil and water, which has to be immiscible. Immiscible liquids means which should not get mixed with each other. Okay, it should not get mixed with each other. Okay, and now what happens? You have the stopcock here. So once I open the stopcock, first obviously the water, which is a denser liquid, it will start coming out, right? It will start coming out. So at one point where the almost the last drop of water is about to come out, you need to close the stopcock, because now in the beaker you have collected water, and in the separating funnel you have only oil or the kerosene oil, so you can use another beaker and collect it also. है ना? Yes, so separation of immiscible liquids is very easy, है ना? हाँ. But the problem is how to separate the miscible liquids. See, depending on their densities, they will be separated out. है ना? Oil, water, kerosene, water, petrol, water. So it is very easy to separate the immiscible liquids. Now, what are the applications? So to separate mixture of oil and water. So even what happens, iron, so metallurgy mein, so we'll take iron ore. Okay, so lightest slag is whatever the wastage that comes, that will be formed during the formation of molten iron. So that which is being lighter, okay, it will be at the top. So it will be collected at the top, and the molten iron which is denser, so at the bottom of the furnace. So if this is how the furnace looks, okay, so first the molten iron will come out, and then molten iron which is being denser, so it will come out at the bottom, and the molten slag will be collected as it is lighter. Why? See, if it's at the top, then how will you collect it? So this is how we hold the separating funnel. This is how we hold the separating funnel. That's nice. Thank you so much. Yes, Lavya. Very soon. Okay. Next is sublimation. So we all use naphthalene and camphor. Camphor. Burning and naphthalene balls near the sink and in the wardrobes and all that. But we have never seen those naphthalene or camphor getting converted into liquid state. So they will just vanish one day. Where did they go? So these are sublimable substances, sublimable compounds which directly gets converted into gas without going to the liquid state. So that process is what is known as sublimation. So for example here, if the mixture contains one sublimable substance and the other one which is not, so using the sublimation we can aram se separate the sublimable from the non-sublimable compound. So for example here you have ammonium chloride, okay, and salt, NH4Cl plus salt. Okay, take it in a china dish, and we are using the inverted funnel with a cotton plug, because we don't want ammonium chloride to escape, we want to collect both. So once you start heating the ammonium chloride plus salt mixture, so salt being non-volatile, come on, it will just stay there, right? So ammonium chloride, as it is sublimable substance, so once you start heating, it directly gets converted into vapors, and once it is passing through it, obviously it has no way out. So because of the cotton plug, so it will undergo condensation, there only condensation, and the ammonium chloride will be collected here. Now you have salt in the china dish and ammonium chloride in the inverted dish, inverted funnel. Yes. It's buffering? Is it okay now? Hey Pallavi, no dear, I'm not. Hey Samhita. It buffers for a while. Acha, is it fine now? Yes, I'm so sorry, I don't know. Hey Shahid, hey Adi. No buffering. Acha, hey Sanju. Yeah, it's okay now. Cool. Next is distillation. See, for immiscible compounds, acha ji, chalo, we use separating funnel. But if it's miscible, for example, you take acetone plus water. Acetone, nicely it gets mixed. Completely it gets mixed with water. Now I want to separate acetone and water. What is the way? So if the mixtures are miscible, then and if their boiling point difference is greater than or about 25 degrees Celsius or Kelvin, you can use this distillation technique. So what it is also very simple. Okay, you have the mixture here. So obviously acetone ka boiling point is less. Okay, and once you start heating it, so what happens? Acetone, which is volatile compared to water, it vaporizes first. Okay, once it reaches its boiling point, it starts vaporizing and then it will enter the condenser. So you can see the cold water inlet and the hot water outlet. So the cold water, which is continuously passing through this condenser, it will absorb all the heat energy from the vapors. So liquid, gas to liquid, that is, it will be, the vapors will be condensed and you can collect acetone on the receiving beaker. Okay, so what are we using here? First thing, so there is difference in their boiling points, which has to be at least minimum 26 to 27 degrees Celsius. Okay, above 26 to 27 degrees Celsius. So obviously acetone with low boiling point, it vaporizes first and then it undergoes condensation in this condenser and you will receive the acetone, and water is here in the distillation flask. So you have successfully separated them, right? Okay. Now, if the boiling point difference is greater than or above 25 degrees Celsius, okay, distillation. Alcohol and water may, the boiling point difference is 22 degrees Celsius and not above 25 degrees Celsius. You cannot use distillation technique, then you have to use the fractional distillation. But look carefully. Okay, what is the difference between distillation and fractional distillation? It has a distillation flask, thermometer, you can see the burner, okay, and the beaker, receiving beaker hai, condenser is same. Okay, here also you have distillation flask, beaker, and then condenser, thermometer. Then what exactly is extra here? What is the difference? It is this fractionating column. Okay, so it is the fractionating column. So what happens? So this fractionating column is filled with these glass beads, so which will provide the greater surface area for the continuous evaporation, vaporization and condensation, because alcohol plus water, as the difference in the boiling point is very less, so obviously alcohol vapors will be more, but there will be some very small amount of water vapors also, which we do not want. So once they touch the cold surface of the glass bead, so what they will do? They will get condensed, and water molecule being heavy, it falls back to the distillation flask, and the alcohol vapors, so they will be, because of the vapors raising in the flask, the fractionating column, so which will help in the vaporization of those vapors. So at the end, at the top, you will find only the alcohol vapors and not the water vapors, which will go to the condenser and you can collect the alcohol there. Okay. So what are the applications of fractional distillation? See, separation of different gases from air, the components of air. That's a big question, right? How can we separate it? That can be done using fractional distillation, and the different fractions of the petroleum products also can be separated by the fractional distillation. Okay? Yes. So crystallization, what is crystallization? So someone asked me, ma'am, you have a solution, saturated solution, we have heated it, so it has dissolved more amount of solute, but what happens when we decrease the temperature, when it is cooled down? So those excess solute which has been dissolved by that solvent, it will start coming out in the form of crystals which will be 100% pure. So this technique is what is known as crystallization. So it's a process that separates a pure solid in the form of its crystals. So for example, it contains some soluble impurities. So you cannot separate it by filtration, evaporation. If you try evaporation, it will just contaminate the solid. Then you can use this crystallization technique, in which you will always end up getting 100% pure compound. So yes, so what happens here? We'll take the salt and then we'll prepare a saturated solution of it. You need to heat it. Then the hot solution, when it starts cooling down, the excess of solute, it will start coming out in the form of crystals, and those crystals you can just filter them. You will end up getting the pure substance. Yes? Okay. So what are the applications of crystallization? Purification of salt that we get from seawater, because only if you use evaporation technique, okay, or the vaporization technique, so you will end up getting rock salt which is not pure. Okay, there are other salts also in the seawater. It does not only contain NaCl, right? So if you want to get the pure salt, then we'll use crystallization. And the alum, that is, they will use for the purification of water. Do you guys know? Yes, it's so easy, acha. Okay, so that is also the application of crystallization. So the last technique is chromatography. So what happens here in the case of evaporation, vaporization technique, we saw, right? So the components, we could separate dye from water, but dye is also a mixture of different pigments. If I want to know what is present in black dye, what is it made of, what are the pigments, of course by evaporation technique though you cannot determine. So then we will go for the chromatography technique. So what is the principle of chromatography technique? Is the components of the mixture should have different solubility. It should be dissolved. It should dissolve in the same solvent, but it should have different solubilities. That is what is the principle of chromatography. So what happens as there is difference in the solubility? So when you place this filter paper, okay, so we have taken the filter paper and then we have placed the spot of ink, and you have to place it in such a way that the spot of ink should not be immersed in water. It should be just above the water level, and then as it is filter paper, the water gets absorbed and then the water starts moving up. Along with the water, as this whatever the pigments present in the dye, as it is also soluble in water, they also start moving up. So if that pigment is more soluble, so it will be at the top. If it is less soluble, it will be at the end. So at the end, before it reaches the top, you have to remove the filter paper, so you will be able to see different spots. Now I can say, acha, so there is this red, yellow, green pigments present in the dye. So this is how the chromatography works. Okay, chal. So what are the applications? To separate colors in a dye, to separate pigments from natural colors, and to separate drugs from blood. See, there blood test mein you will know. So what is the number of your WBC and RBC, and is there anything, the cancer cells and all that there. But if there is any drug present in your blood, so that can be known by the chromatography technique. Hey Samyak. So in today's session, we learned as matter around us pure revision. So we are done with it, people. Thank you so much. I know I took more than 45 minutes, right? I thought, I'll just briefly explain everything so that you won't have any doubts. हाँ जी, खत्म हो गया जी. Okay. Hey Tanmay, hello. Yes. All the chapters. It's too long, acha. But we have to cover everything, no? Okay. Thank you so much then. So, if you like the session, make sure you have liked the video and share this with your friends also. And if you are here for the first time, do not forget to subscribe. And as I told you before, there will be a mentee battle. Okay, so we will be having one shot revision for other chapter 2, and make sure you attend that session. So, and then let's see which chapter is easy, which chapter are you very good at. And if you want to take up the pro subscription and want to solve all of your problems, just visit the link given in the description box and click onto it. Choose your grade, board, Click onto the get subscription. Do not forget to use the coupon code SURPRO for additional 20% discount. If you don't use the coupon, आपको discount नहीं मिलेगा. Okay? Thank you. Yes. Chalo, I'll see you soon then. If you have any doubts related to this chapter, please let me know in the comment section. Thank you. Bye-bye. Hey Samita, thank you so much. Bye bye Siddharth, bye Srilata. See, as I told you, we wanted to have mentee battle, so that is the only reason we don't have a mentee today. Please don't feel bad. Okay? I had mentioned this at the beginning. Bye bye. So thank you so much. Oh, when is Ask Me Anything? It's on Friday at 1 p.m. If you have not asked me anything, so the Google form is available in the description box, so you can, if you have any questions for me, you can let me know that. Bye bye. Thank you Sanviji.